Welcome to Season 2, Episode 13 of Tech Talk Thursday. My guest today is Matt Wrosh, Senior Product Manager at EMD Performance Materials. Matt is here to talk about a new sintering process that offers significant performance and cost benefits for SMT assembly and advanced packaging applications. That's the topic today. Now let's meet our guest. So Matt, nice to see you again. We had you a few months ago actually on one of our panel discussions, but how are things holding up down there in Southern California?
Well, I guess the state was just shut down again, so we're doing what we can. Of course, it's unique times for everybody all over the world. Certainly, Southern California is not exempt, but on the bright side, it is still 72 and sunny today, so things could be worse.
Good. All right. So today we're here to talk about a topic of transient liquid phase sintering. Now, sintering's been around for a long time. It's used primarily in high temperature interconnections, but it involves usually a hardware component where you basically apply pressure to the soldering joint. How does this system you have with transient liquid phase sintering, or TLPS, how does it differ?
That's a great question. So fundamentally, it's also a sintering system, right? We're starting off with powders that aren't reacted, and through processing, we're going to form a solid mass. The difference between our material is that the transient liquid phase is really an assistance for the sintering process. And so unlike a traditional silver system where you might be putting it under pressure and temperature, with ours, there's no pressure required. And that's because the liquid phase helps bring the other powders together. So we formulate a combination of copper powder or silver powder and solder alloy powder. And once you hit the reflow temperature of that solder alloy, it completely reacts with the other metals, drives intermetallic formation, and then there's no solder left. And so you formed a solid mass, and it will not remelt at the same process temperature. So that's the fundamental difference, I guess.
Right. So it literally is a straightforward reflow process that we use in normal manufacturing. There's no additional processes required to make this happen.
That's right. Yeah, it's a little bit different on the print designs and the print patterns, but as far as processing it, we do require nitrogen because of the copper powder and the other powders that are in there, and we're down to type 6 and lower. So there is a nitrogen requirement. Mm-hmm. It's an inert atmosphere, but there's no pressure required like a nano sintering paste that's just thrown through our reflow profile. Typical peak temp for like a lead-free solder, and that's how it's processed. Yep.
Right. Now you mentioned there's quite a high there's copper content in it. What is the alloy composition in your Well, in fact, let's start because you've got various versions of it, haven't you? You started out with the PCB side of the business, so let's start with that one.
Sure.
Tell us a little bit about the origins of it.
Sure. Yeah. I mean, all of our formulations, I'll dial back a little bit. All of our formulations are similar in that they're a combination of copper powders and a solder alloy. It really comes down to the ratio of the two that differs for the different applications, and then the solder alloy also can change depending on the process conditions. So for printed circuit boards, where you might be running laminations at 190 Celsius, we need an alloy that's going to melt below that to drive the TLPS process. So our printed circuit boards are usually bismuth-based alloys, or a blend of bismuth-based alloys and other tin alloys, but still predominantly copper. So for us to make the system work, you need more of the metals that are reacting with the tin to pull it out than you do more tin. Otherwise, it's going to act more like a solder. So in the printed circuit board application, what we do is basically fill vias, or we fill lamination adhesive layers with our paste, and those get put into between the cores, and we can join copper cores and copper bond pads and things that are typically used with copper electroplating to connect, and we use paste approaches. So we get a single lamination with that printed circuit board approach in our paste.
Big data, artificial intelligence, and smart factory solutions are here now. Automated optical inspection is critical in a smart factory environment. Leading the way to Industry 4.0, Murtech invites you to the smart factory of the future.
So I'm guessing with the high copper content, that makes it very cost effective.
It does.
Yeah. Okay.
Absolutely. Yeah,
And
no, copper is cheaper than silver and gold and other precious metals, right? So
right. And so obviously against things like conductive adhesives and that sort of thing, it's going to be very competitive. What about examples of when you might use TLPS versus SAC 305?
So in applications where you've got multiple reflows or assembly processes that are going to require multiple reflow steps, right? I mean, if you can get away with solder, we recommend you do it. But if you need something that's going to have multiple melts, or if you're afraid of tight pitch applications where things might move if they get close to that temperature, once ours react, it's set. And so you can put it through as many reflows after that as you want. It's not going to change properties. It's not going to move. There's no potential for reballing or anything like that. So, so that's an example, of where we would use it against SAC 305. And we're also finding that in embedded printed circuit boards, that's also proving to be true as well. So those are a couple areas where we play with TLPS and PCBs.
Right. And you've also got a couple for packaging applications.
Yeah. So we were part of the DA5 consortium over in the EU for a long time, and that was TLPS is targeted as one of the approaches for that. And so naturally, for things that are trying to go lead-free, our material is also attractive for that, because once we react, even though we don't need the lead reflow temperatures, we can still do it at a typical lead-free reflow profile, but it doesn't melt until well beyond 400 or 500 Celsius. So in applications where maybe you're only using lead because of its temperature stability, this is also another unique assembly material as an alternative to high lead solders for that reason.
Right. So let's talk about some of the specific applications that you would use it for. Where would you typically specify this?
So for our die attach, for example, like I said, actually that varies, but for high lead applications where dies are small. So we have done positive space design of experiments and found that, we can't go to enormous die. We do get stresses that aren't as forgivable as high lead, but for smaller die and match CTE type of applications, we think it's a very good alternative to high lead as a die attach. For other applications where you're using gold tin, be it for military or for high thermal conductivity, it's also a unique chance at cost reduction, right? From a gold-based solder. Particularly our DAP 491 now has thermal conductivity that's on par with gold tin. So all of the benefits that you would get from gold tin, which really are thermal conductivity and stability through thermal excursions, we can now deliver through our 491. So we're targeting that for gold tin applications. And then really anything that has high temperature requirements that are being worked around currently through either brazing or other unique alloys or unique polymer systems. This is another system that can be processed at low temperature or at least moderate temperatures and withstand up to 400 or 500. So it really depends on the application and the customer needs, where we define the various products that we have now for, die attach versus passive component attach, et cetera.
Right. Okay. So I mean, other than the PCB materials, these other materials for die attach and for regular interconnection applications, that's a relatively new family of products.
That's right.
And I take it they're available now, are they? Are they
Yeah. So we have 5 products that are rolled through production and production controlled, commercially available, and they are available, and we're actively marketing it and trying to get samples out there. So.
Great. Well, it's great to see new things coming out, especially during all the restrictions we're all facing with COVID. So I want to definitely thank you for coming in and telling us a little bit about these new transient liquid phase sintering materials today.
My pleasure. Thanks, Trevor.
Well, that's it for another edition of Tech Talk Thursday. Join me next Tuesday, December 15th, for a great panel on the do's and don'ts of selective soldering. Until then, stay safe and have a great weekend.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.